Okay, everyone, today we are going to solve this problem 5 right here from week 2. So, computing the final amount of some compounded interest given this equation and using Python. So, we have a Python shell open. Control O will just open up the shortcut to opening a document or file. We have everything saved in this, and I saved this particular problem as YouTube one. So initially we're going to set P equal to 10,000, um, which is the principal amount. So we're going to start out with 10,000. We're going to multiply that by 0.08 right here, as the interest rate is 8%. That translates to 0.08 for the value of R, and we're going to assign the value of n to be 12 right here. And so we're going to want just a general number of years of compounded interest. So we're going to enter response and assign that input, the function input, and have years, or enter years compounded. That way the user of the code can just enter as many years as they need to. Say they're trying to figure out after 10 years, then they'll just enter 10. After 15, they can enter 15. So really it's n amount of years. You could figure out like as many years as you can think of, We're going to have t right here, so it's to the n times t. So we're going to have t equal, we have to float in our input response. And then we're going to have our total amount equal, and then we're just going to simply add the formula in, p times 1 plus r over n to the n times t. And then finally, we're just going to print the final amount is, we're going to use the print command, and we're going to have the final amount is, and then comma, total amount. It's always important to put a space right here, so it will have the final amount is, and then there will be that space, so it's not so conjumbled. If that is a real word, I don't think conjumbled is, but we'll go with it. So you all save your code first. File, save as. It's already saved as YouTube one, but we are going to change this to homework underscore 02 underscore ex underscore problem 5 YouTube .py, just so I can turn it in a little bit easier. We're going to save that, and now that it's saved, we can run our code. So enter years compounded. We will start out with 4 years compounded. The final amount is, and then it gives us our final amount, 13,756 and some change. Let's just go back to our code real quick. So let's run it one more time. Enter years compounded. Let's try like 6. Well, it gives it to you in scientific notation because it's such a big number. But as you can see, really, you can just keep running the code for as many years as you need to, half a year. And it just shoots out your final amount, which is exactly what we wanted. So now that our code works, we can double check with the calculator, but I did double check with the calculator, and the code is actually generating the correct final amount. So I will say that problem 5 is complete with this code. So thank you.